Okay, here we go. This is an intro to sequence and series. It is found in chapter 8 in your book. A sequence is a set of numbers with a particular order or pattern. Each number is called a term. A finite sequence is a sequence with limited numbers of terms. So an example would be like 1, 2, 3, 4, 5. There's only 5 in there, and we're done. Infinite sequence is a sequence with unlimited terms, not ending. An example we could go 0, 1, 2, 3, 4, 5, and so on. That is actually the set of whole numbers, but we don't know when it ends, so it's infinite. Term notation. The first term in a sequence is denoted by A sub 1. Each subsequent term is denoted A sub n, where n is the term number in the sequence. So if I'm giving you a sequence 1, 5, 9, 13, 17, and I want you to identify the following term values. Well, the first two are easy because we can tell from what we've got here. The first one is 1. The fourth one is 13. But if I was going to have to find 9 and 12, I'd have to look at that sequence. I'm adding 4 each time. So I'd have to keep adding 4, and I'd have 21, 25, 29, 33 would be the ninth one. Then if I wanted to find the 12th one, I'd add 4 again and get 37, 41, 45 would be the 12th one. Sequences can be functions. Since each term value is paired with exactly one term number, a sequence is a function with the following properties. The domain would be like your x's or your input. The domain is a set of term numbers, the 1, 2, 3, 4, 5, etc. The range is a set of term values, the value you get in the sequence. So like 1, 5, 9, 13, 17, etc. An infinite set, the domain is the set of natural numbers. Recursive formulas is a rule in which one or more previous terms are used to generate the next term. The Fibonacci sequence is one of these recursive formulas. It is 1, 1, 2, 3, 5, 8, 13, 21, etc. What you are doing is you add 1 and 1 to get 2, 1 and 2 to get 3, 2 and 3 to get 5, 3 and 5 to get 8. So the next one is the addition of the previous 2. So the general formula for this would be AN equals AN minus 1 and AN minus 2. We're getting to the 2 previous terms. So we're going to find the first 5 terms of each sequence. A sub 1 is 14. And our formula is going to be a sub n minus 1 plus 9. That n is greater than or equal to 2 is making sure our term is not a negative number. So if we look at this one, we're putting 14 as our first one. We put that in here. 14 plus 9 is 23. Now I put 23 in there, plus 9 is 32. Put 32 in there, plus 9 is 41. 41 in here, plus 9 is 50. On the second one, we're going to take the first term, multiply it by 2, and then minus 5. So the first term is 6. 6 times 2 is 12, minus 5 is 7. 7 times 2 is 14, minus 5 is 9. 9 times 2 is 18, minus 5 is 13. And the last one will get 21. On the next one, example 3, you're putting a sub 1 in there, adding 6, and then dividing by 3. The first one is 354. So you're putting that in there, adding 6 divided by 3, I got 120. Put 120 in there, add 6 divided by 3 is 42. Put 16 in there, divided by 3. You're going to get 22 over 3. I think I might have skipped one. On the last one, it's 3 times 4. There's the first one. The second one, 3 times 4 would be 12. Now 12 times 4 is 48. Now 12 times 48 is 576. The next ones are the harder ones. You've got to try and figure out what the pattern is and write the rule. So if I looked at this one, I'm taking my first term is a sub 1 is 4. And so my general formula is going to be, it's 3 times a to the n minus 1 minus 1. 3 times 4 minus 1 is 11. 11 times 3 is 33, minus 1 is 32. And that would keep working. If we keep putting the pattern in there, we've done so many of those, I'll just tell you the next 3 would be 851, 2552, and 7655. But like I said, the hardest thing I think sometimes is figuring out the pattern. So on the next one, a sub 1 is going to be 100. And my a sub n, I'm taking 1/2 the a plus 10. So if I put 100 in there, 100 times 1/2 is 50, plus 10 is 60. 40 times 1/2 is 20, plus 10 is 30. 30 times 1/2 is 15, plus 10 is 25. And the next 3 on this one, you end up with decimals, and you would keep doing that then. It's 22.5, 21.25, and 20.625. Explicit formula is a rule in which the nth term is defined as a function of n. The previous terms are unnecessary. So like in all the other ones, we were dealing with previous terms to find an answer. On these, we will not. So when we're doing these, like n is going to be, the first time is going to be 1, then n is going to be 2, then n is going to be 3, etc. So if I put 1 in here, 1 minus 3 is negative 2 times 7 is negative 14. Put 2 in here, I get negative 1, I get negative 7. 3, I get 0, so I get 0. 4, I get 1 times 7 is 7, and the next one's going to be 14. So you're going to do the same thing on 8. You're going to put 1 in, then 2, then 3, 4, and 5. I put 1 in, it would be 1/3 squared, which is 1/9. 1/3 to the third is 1 over 27. Then its fourth is 1 over 81. The fifth is 1 over 243. And then it's 1 over 729. Again, you're putting 1 in, then 2, then 3, and keep going. 1 squared is 1 times 4 is negative 4. 2 squared is 4 times negative 4. It's going to be negative 16. 3 is 9 times negative 4 is negative 36. 4 would be 16 times negative 4 is negative 64. And you put 5 in there, you get a negative 100. On the next one, you're going to put 1 in for both of the ends. So it's going to be 2 times 6 is 12. Then it'll be 4 times 7 is 28. Six times 8, it would be 48. And then it's going to be 72 and 100. Again, you're putting 1 in. I'll write these down. It's 1, negative 2, 4, negative 8, and 16. And you're putting 1 in. You'd have negative 3 squared is 9. 2 in, you'd have negative 2 squared is 4. 3, negative 1 squared is 1. 4 would give you 0 squared is 0, and 1. All right, once again, we're going to try and write the rules for these. And again, remember you're putting in for n, 1, 2, 3, etc. So whatever term I'm looking for, a sub n, it's negative 2 times n minus 5. Because 1 times negative 2 is negative 2, minus 5 is negative 7. 2 would be negative 4, minus 5 is negative 9. And if we continued that pattern, you'd end up with negative 17, negative 19, and negative 21. So in example 14, I have 3, 6, 11, 18, and 27. This time, the a sub n is I'm going to take n and square it and add 2. 1 squared, 1 plus 2 is 3. 2 squared, 4 plus 2 is 6. 3 squared, 9 plus 2 is 11. And if you continued the pattern, it's 38, 51, 63. Remember on these, you're putting for n, 1, 2, 3, 4, etc. On 15, your a sub n, you're taking 1 plus 3 and dividing by 2. 1 plus 3 is 4, divided by 2 is 2. 2 plus 3 is 5, divided by 2 is 5 halves. And if I continue the pattern, I get 9 halves, 5, and 11 halves. The last one, you're taking the square root of n. So a sub n equals the square root of n. The square root of 1 is 1. Square root of 2 is 2. Square root of 3 is 3. Square root of 4 is 2. Square root of 5 is 5. So then you'd have square root of 6, square root of 7, and if we'd reduced it, 2 square root of 2. So like I said before, if you're having problems, it is in chapter 8 in the book, but I don't think this first part is too hard. So good luck, and we'll see you on Tuesday.